Hi, welcome back everyone. I hope you guys enjoyed our first semester together and let's have a great second semester. So, second semester starts out with statistics unit. Learning target 8 and 9 are statistics. LT8, I can summarize, represent, and interpret data on a single count or measurement variable. So some of this stuff are new to you, but I think these are very interesting topics. So we have broke up our learning target 8 into 5 sessions, and then after session 6 will be review, and then skill check will be available on Canvas. So before I start taking notes, can I play 1-minute video? Can you guys stay tuned and watch this part?
Curve, also referred to as normal distribution or Gaussian distribution, is called that way because this is how data tends to be distributed quote-unquote normally, and, well, the graph used to display this distribution looks like a bell. We come across that in day-to-day life a lot. For example, if we take all your local university students and make height measurements, most people will be of average height, meaning that in a graphical representation, most values will be in the middle. Then at the extremes you have, of course, people who are very tall or very short. The same tends to happen when we measure anything from people's shoe size to their IQ. A statistician will, of course, point out that when data is distributed in this manner, the mean, which is also known as the average, is equal to the median as well as the mode, with the bell curve having exactly one mode. The bell curve is also, as can be noticed, symmetric. If you draw a vertical line at the mean, two mirror image halves result. Finally, if you know the mean, you know where the center of the bell curve or the proverbial top of the bell is, and if you know the standard deviation, you know how spread out the bell curve is. The larger the standard deviation is, the more spread out the bell curve will be.
Okay, so that video showed you the bell curve or normal curve and explained a few things, but let's just summarize what we just watched. So a normal curve is it's a distribution of a data. So you get set of data, and this is how the whole data is spread out. Set of data set that is, as we have seen, is symmetrical and creates a bell-shaped curve. It creates a bell-shaped curve and it's symmetrical. And the cool thing about normal curve is that mean, median, and mode are all the same. I mean, I'm sure you've seen mean, median, mode, right? Mean is the average, median is middle, and mode is most often. It happened to be all the same if it's a bell normal shaped curve. For example, like the height, as the video mentioned, height of the people could be a bell curve, everyone's shoe size, IQ scores, even like a salary of everybody, or SAT scores. So there are many things in life that tend to be a normal curve. Now, things you haven't seen before. Standard deviation. This symbol, it's called sigma, lowercase sigma. That stands for standard deviation. What it is that this is a measure of spread for a set of data. So there is going to be the middle, the median and the mean. But you know how sometimes different other data points can be like wide apart or maybe far away from the average, or sometimes they can be close to the average. So to tell that, that's a standard deviation. Which means if you have a higher standard deviation, that means the data is more spread out. I'll just do the arrow. Spread out. So if I were to have a graph, it'll be a bell shape, but because it's more spread out, it'll be like kind of like a long bell like this. Does that make sense? And same, if it's lower standard deviation, then it's less spread out. All the points are gonna be like pretty close to the center, so it'll be just kind of like a tall mountain, not spread as much. But that's what it means if it's lower standard deviation. So things are like close to the average. All the values are mean or the average. Now that symbol right there is called mu, like Pokemon Mew. Mew. It looks like a U with a line before the, it's like a U with a little line. So that's mu, and that stands for mean. And mean or median in a bell normal curve would always be, well, that would be always in the center. Mean means measure of center. So it is always in the center. If we're talking about normal curve, and we're gonna only talk about normal curve for our learning target 8. So the graph looks like this. You see how so this is going to be the mean because this is the average in the middle, in the center. And then so if let's say mean is a 0, because that's your standard deviation, mean will be 0 because you're already in there. And then how much is spread out? We call it like +1, +2, +3 standard deviations away. And then the other direction will be -1, -1, -2, -3. This is how much standard deviation from the mean is. Okay, so let's take a look at some example of how we can use that information to figure these out. Number 1, the average amount of money spent on groceries by the adult American can be represented by a normal distribution that has mean of 127. So mean 127 means that is in the center, $127, and the standard deviation of $14. That means each of this tick mark or this bar will be $14 away from the center. So this way it'll be it's $14 more, so that would be 141. So if you go another bar, that'd be another $14. That's now 2 standard deviations away, that'd be 155. And then one more $14, 169. Now, can we do that going the other direction? Yeah, so standard deviation of 14, so we got to take away 14 to get to the next bar. So it'll be 113. And now going back one more, it'll be 99. And then one more would be 85. So in number 3, we're going to talk about how many people are in these different standard deviation away, like what percent of the people are in different parts. But right now, we just need to figure out what the center is or mean is, and then all these numbers at each bar for this this part. So letter B. The average number of points scored by the winning team of an NFL is normal and its mean is 29. So the middle is 29. Really simple. Find the middle, put 29. Standard deviation of 9. So that means for each bar, it's like 9 more. So it'll be 38, 9 more. 47, 9 more. 56. Now we're going the other way. Yeah. Take away 9, so it'd be 20. Take away 9, it'd be 11. Take away 9, it'd be 2. Done. That means very little team can win the football game with 2 points. Very, very little. I mean, we'll talk about those. Let's look at the credit score. Credit score falls between 380 and 850 points. The average credit score can be represented by the normal distribution, has a mean of 673. So that's in the middle. And then standard deviation of 58. So 58 more, 58 more, 58 more. Do I need a calculator? Oh boy, I guess. 673 plus 58. I hope you guys got there before I did. 731 plus 58. 789 plus 58. 847. Now going the other direction, take away 58. So because standard deviation was 58, 615, take away 58, 557, take away 58, we got 499. There you have it. All right, let's finish with number, well, there are a lot more examples, and of course we're gonna do this in class. So I'm gonna do about 3 examples from number 2 as well. So number 2, now here, let's do, given the following scenario, answer the questions below. A set of data has mean of 80 and standard deviation of 6.1. So let's figure that out first before we do anything else. So 80, we're gonna go 6.1 this way, so it'd be 86.1. We're gonna go 6.1, 86.1 plus 6.1, 92.2, plus another 6.1, 98.3. Let's go the other direction. 73.9, 67.8, and then, so we're just going 6.1 each time, okay? That'll be 61.7. So do you see how these questions asking what is plus 2 standard deviations from the mean? So if it helps, you know what? I would do this. I would put it the zeros and plus 1s, plus 2s, and plus 3s, and minus 1s, minus 2s, and minus 3s on my graph so I can tell which is which. Plus 2 standard deviation from the mean would be 92.2. Minus 1 standard deviation from the mean would be 73.9. 0 standard deviation from the mean, that means it's just staying in the center. Minus 3 standard deviation from the mean is 61.7. Look, minus 3, 61.7. So that's just how you do it. I feel like this is gonna be, you see, all it is just like you know how to add and subtract. I'm gonna end right here, and I will see you on part 2. Please come to class and ask questions if you have any. Bye!